Okay, so plate boundaries. Why do we get earthquakes? Why do we get volcanoes? Why did we see those patterns we saw in the lab? Okay, and the reason why we see those is different types of plates will interact in different ways. Okay, if we go all the way back to this drawing down here, okay, we will see that some plates, like the Pacific plate here, this is the Pacific Ocean. There's no land on this plate. This is all of the rock that is underneath the ocean. Okay. Then over here we have the North American plate. The North American plate is a mix of ocean over here on the Atlantic side, but also continents over here. So what we see here is when the Pacific plate moves this way and the North American plate moves this way, we have oceanic crust. We have the rock underneath the ocean going and connecting with the rock that makes up a continent. Okay, and because those are two very different things, we're going to get some pretty interesting interactions. So let's go back to here. And as I'm going to be doing this, I'm going to be making some drawings. It would be a really good idea if you made these drawings in your notes as well. Remember, we're uploading these notes onto Schoology when we're done. So we're going to have two plates here. Our first one is continental. I'm going to draw that as green. And our continental plate is going to be a little thicker. Okay, it's going to be maybe about that big. I'm going to draw a C on it for continental, and I'm going to indicate it's moving this way to the right. Okay. Moving along with that is now we also have an oceanic plate. Oceanic plates are thinner, so it's not going to be as thick. It's moving, this is convergent, so they're moving towards each other. So this plate's going to be moving this way. And oceanic plates are going to go under the continental plate. That's because oceanic plates are more dense than the continental plates. Okay? Because it's more dense, it's going to sink. The continental plate is less dense, so it's going to float on top. Okay? And all of this is all on top of the asthenosphere. The asthenosphere is the layer of the Earth down below this. Okay? Here on top of our oceanic plate, right, we have, it's an oceanic plate, we have the ocean. So here we got a little bit of ocean here. Okay, and the ocean is just water that's on top of this oceanic crust. Okay, and over here we have the continent. No water on top of the continent. There might be some rivers and lakes, but nothing super important. As our oceanic crust moves down underneath our continental crust, it's getting hotter and hotter, right? The deeper you go down into the Earth, the hotter the Earth gets. So this oceanic crust is going down into the Earth. This rock that this oceanic crust is made out of is getting hotter and hotter. And what happens when things get really, really hot, things like metals, things like rocks, they start to melt. So this oceanic crust is going to start to melt when it's down here. Okay? And when rock melts, what does it become? It becomes something called magma. So this rock is melting and it's becoming magma. So this liquid hot magma, now it's hot, it's become less dense, it's a liquid. This liquid hot magma is going to start rising up. And as it rises up, it's going to kind of like work its way through the cracks in the continental crust. It might also melt some of the continental crust. So it's kind of going up, going up, going up. This liquid hot magma keeps on rising up through the continental crust until eventually it hits the surface. Now, when it hits the surface, is this magma just going to stop? Is magma like, all right, we made it, we're done, we're going to stop doing anything fun and exciting? No, of course not. Our magma is going to start shooting out of the earth. Okay, what do we call it when magma or lava shoots out of the earth? What do we call that feature? What do we call that landform? That is called a, you guessed it, volcano. Okay, so here now we got this volcano. This volcano is made up of now solidified liquid hot magma. Okay, that came up through the crust and then went up to the surface. And then it's a volcano, so let's throw some smoke onto it. This is how we get volcanoes. Long and short of it, we got our continental crust, we got our oceanic crust. As that oceanic crust descends down into the earth, into the asthenosphere, it begins to melt. And as that rock melts, it starts to rise up. And then once it hits the surface, it starts what we call a volcanic eruption. That magma starts kind of spewing out of the earth. Eventually, that magma builds up and builds up and builds up into the shape that we call a volcano. So when you were looking at your lab the other day, you saw all those volcanoes at all of those plate boundaries. This is why. This is one volcano, but all along this plate boundary, we're going to get more and more and more of these volcanoes. Excellent. So that's the big one. That's why we get our volcanoes. Okay. Here we have another one. This is oceanic and oceanic. The idea is basically the same here, but instead of having our continental crust here, right here, we're going to have a second oceanic crust there. We still get volcanoes at an oceanic boundary. Okay, so we're going to skip that one. The other big one that we have is a collision zone between two continents. In this one, we're not getting a volcano. So here I'm going to start drawing it. We have one continent here. Remember, continents are thicker. So there's my continent, and it's moving this way. And then we have a second continent right here. And it's moving the opposite direction. Remember, this is convergent, so they're moving towards each other. Okay. And again, just like before, these are resting on top of the asthenosphere. There's nothing below them. There is something below them, and that something is the asthenosphere. So we've got one continent going to the right, the other continent going to the left. It's kind of like watching a car crash in slow motion. What is going to happen to both of these continents? They're going to collide, right? That's why we call it a collision zone. So what is going to happen when these collide? So this keeps on going this way, this keeps on going this way, and then they collide even more. That goes that way, that goes that way. And then they're going to start squishing. They're going to start crunching into each other. And when that happens, we start getting parts of the crusts rising up. They're kind of squeezing up out from in between these two plates. So we're having rocks that are going to start squeezing up and out in between these two plates. And we got some more squeezing here, and more and more. And what this is the two pieces of continental crust are crushing together. And as they're crushing together, the fronts of them start to get folded, and the fronts of them start to get deformed, and they start getting all crumpled. This is actually scientifically, this is called the crumple zone, because it's where the two continental plates are crunching together. Okay, and that's going to start making the landscape rise up. Okay, and what do we call these really, really high areas of landscape? These are called mountains. So this is how our really, really tall mountains that we see around the world today, this is how these are formed. These are places like the Himalayan mountains in Asia. These are the tallest mountains in the world right now. They're formed from this. Okay, the Rocky Mountains out west, these were formed the same way. Okay, the Appalachian Mountains over here on the East Coast, I'll write that over here. The Appalachian Mountains over here on the East Coast were formed exactly the same way. Okay, except that happened 250 million years ago when Pangea was formed. So those mountains are very old and they've been weathered and eroded since then. So they're not nearly as high as they used to be. But when they were high, the Appalachian Mountains were as high as Mount Everest is right now. Okay, those are our two convergent boundaries that we need to worry about. We've got the continent and continent, where we get these two continental plates crumpling together, colliding together almost like a car crash, and we get a folding of mountains in between them. And we have our continent and our ocean, with the ocean going underneath the continent and creating a volcano. Okay, we're going to stop there for convergent. We're not going to talk about divergent, the boundaries moving apart today, nor are we going to talk about transform boundaries, the boundaries moving alongside each other. I think we're going to talk about those tomorrow. Okay, so make sure you've taken notes. If you need to, go back in the video. I'm also going to upload these notes on the Schoology, so if you just need to look at the individual slides, they're going to be there for you. Okay. If you have any questions, make sure you let me know in the weekly discussion or through an email or through a Schoology message, and I'll make sure I get back to you as soon as I can. Okay. I hope everyone is well. I hope you're staying safe. I hope you're staying healthy, and well, I'll see you again.